with no calculator. Calculates, so they give us log of 12 and or log of 3. So we have these two. So they asking us write the following in terms of log of 12 or log of 3. A, log of 4. B, log of 9. C, log of 36. All right. I believe I solved a very similar question in one of the videos on YouTube. So that was for log of 4 and log of 3, but this is log of 12 and log of 3. So log of 4, when you see this log, the base is 10, we can easily use the calculator. But they ask us to write log of 4 in terms of log of 12 or log of 3. And anytime they say no calculator, that means you need to go through your note sheet and get all the formulas and properties for log. So I'm going to list them here. We start with having log of a to the exponent m. This is m log of a. Let's say b, the base is b. Then we have log of a plus log of b equal to log of a multiplied by b. Log of a minus log of b equal to log a divided by b. Correct? We have page of note, or you have Google that you can see all the properties of log. But how do we break the log of 4? So I mean, on this type of question, only focus on 4 and see how can you get 4 from 12 and 3. Should we add them, subtract them, divide them, exponent? Which one works?
Division.
Yeah, 12 divided by 3, we get 4. So we have some idea. So instead of this 4, so I'm going to write this log right here, correct? But instead of 4, I'm going to put 12 divided by 3. So I didn't do anything wrong. And I carry the log, and I have the log. Instead of 4, I put 12 over 3. But definitely, if I divide 12 over 3, I will get back to 4. They ask us to write it in this form. So so 12 over 3, I'm going to apply this formula. If you have a over b, we write a minus b. So this will be log of 12 minus log of 3. And we are done. We wrote log of 4 in terms of log of 12 and log of 3. Now log of 9. Now how do I get 9 from 12 and 3? Tamir, how can I get 9 from 12 and 3?
I feel like you could use log 3 for that.
Okay. I mean, this 9, I mean, here we said 4 equal to 12 over 3. And we had the formula for a over b.
Yeah.
If you say 9 equal to 12 minus 3, which is correct, but we don't have any formula that is a minus b. we don't see any formula that log of A minus B equal to something. We have minus here, but has log of A minus log of B. We don't have any formula for this one. So that's the mistake if you're going to use that. So we go with Tamir. We only use 9 will be 3 squared, correct? So instead of 9, I can put 3 squared. Now I'm using this formula, the exponents. This 2 will come over here. This will be 2 log of 3.
For that one, would it also be okay to say log of 3 plus log of 3?
Very good, but if you have log of 3 plus log of 3, you will add them up. You get, yeah. I mean, if you leave it at log of 3 plus log of 3, this you use 9 equal to log of 3 times 3, correct? You made the multiplication to addition. But in this case, because we have A plus A, so you need to write 2A, right? You need to simplify it. I think you get error if you get, you don't get full credit for this. You need to simplify to 2 log of 3. But very good. What about 36?
Multiplication.
Very good. This 12 is this 36 equal to 12 multiplied by 3. So the question that you're going to see when they ask you do it like this, that means there is a way to simplify it. So don't think it's impossible. No, it's possible. 36 is 12 times 3. So log of 12 times 3. This will be log of 12 plus log of 3. And we are done. There's another question like this in YouTube that I solve. So with these two, you should have fully confidence to solve any questions related to this. All right, we did one. Let's go 5.1, number 77. 5.1, number 77. Wow, that's a very good question. So let's see if I'm recording. They ask us to solve, and this is chapter 5, section 5.1, question 77. Part A, 2e to power of 3x plus 2e to power 3x equal to 1. B, 3e to power 4x plus e to power 4x equal to b. So they said exact, correct? So the word exact, solve exactly for x. That means no calculator and no taking a picture and solve it. All right. I know it looks kind of scary, but you should be happy that you're able to solve a question like this. We are not dealing with the linear. We're not dealing with the quadratic equation. We're dealing with exponential. So you learn technique to solve the exponential equation. The techniques in your note sheets are, so these are the technique that you should apply. One of them, the basic one, we would like to make them same base. For example, b, if it's 5 and x, then x equal to 5. I mean, if you're able to make the both sides of equal sign same base, then the exponent are equal, correct? That's a basic one. Sometimes we are not able to make them same base. Like 3 to power of x equal to 2, correct? Solve for x. There's no way I can make 3 to base of 2. And this type of question, we take a log of both sides. So we use log. And the last one, if we have like a e to power of x equal to 2, if we have the base e. So your job is to go through the step 1 if you're able to make a same base. If you don't see, you take a log of both sides. If you see e, you take a natural logarithm of both sides. Good, so that's the rule. So with this note, I'm gonna go number 1. So before I solve for x, we need to combine them. We have e to power of x, e to power 3x, e to power 3x. That means we have a and a. So 2 of this, 2 of that, we get 4 e to power of 3x equal to 1. If you see those example I made, the first one, I mean, we had x one side, I mean, the exponent one side, all the number other side. So before you take a log or natural log of this, you need to get it of 4. So I'm going to divide by 4 both sides. Then I have e to power of 3x equal to 1 over 4. So now the party starts. Now you have to show me your skill. Are we able to make them same base? Should I take a log or natural log? We take a natural log because of e. So I'm going to take ln here and make some space and take ln there. Good. So one of the exponent that formula we learned that ln of a to power of m equal to m ln of a. So this exponent will be front of ln. It will be, I don't know why should I change the color that much. We have 3x ln of e equal to ln of 1 over 4. 1 over 4, I'm going to put 0.25. What is ln of e?
1.
So ln of e in your note sheet is 1. So this is gone. Then 3x equal to ln of 0.25. Then x equal to ln of 0.25 divided by 3. And we are done. We're not going to calculate it because they said the exact. Cool. Let's solve another one. Tamir, that was your question, correct? You asked me.
I don't think I asked that one. I don't
Right,
think that one was me.
That means you solve it. Help me on this one. How do you solve this one?
So I think
Combining
you're
them,
gonna,
correct?
yeah, combine like
These two are exactly the same, so we combine them like previous. We have 3 plus 1, we get 4 e to power of 4x equal to b divided by 4. E to power 4x equal to b over 4. Now we take a ln of both sides. ln, this exponent will be here. We're going to have 4x ln of e equal to ln of b over 4. Ln of e is 1. I divide it by 4. I get x equal to ln of b over 4 divided by 4. Then we are done. I know ln of b over 4, we can simplify it ln of b minus ln of 4, apply the formula, but we don't do it. We leave it like this. Simplest one. So we did, wow, 951. We have 5.1 number 9. Rewrite this statement. So this is 5, chapter 5, section 5.1, number 009. Rewrite this statement 10 to power of 3v equal to a using log. So question like this, the first formula, log of a base b equal to c, this we can write that a equal to b to power of c. If I give you this one, you should be able to give me the other one, a log form. So here we need to just map which one is a, which one is b. So this is a base, correct? Because this is a base here. Base is there. So I'm going to write log. So I find b is 10. This is c, which is 3v here, a here, and that's it, 10. So this is the question. This is the answer. 3v equal to log of a base 10. You don't need to write 10. So we have 3v equal to log of a. I divided by 3, v equal to 1/3 of log of a. All right. Please stop me. Yes.
Why is it 1/3 instead of just 3 log?
Okay. So are you with me here? With 3v, 3 multiplied by v equal to log of a. I divided by 3.
Oh,
V equal to.
okay.
Okay. 5.135b. 5.135b. So those are the good questions, but I mean, I would like you guys to spend time on this. I mean, think about it for 45 minutes. Section 5.1, question 035b. Express the following terms of x without log. So we have 1000 to exponent 4 log of x cubed. Looks strange, correct? This is very complex. But you have to go through your note sheet, what property of log we can use for this one. Looks like one of the formula you have, we have like a to exponent log of base a, and if here is x, x will drop. If these two are same, then we are okay. Then we get rid of the log. So let's see, what do we have? This is base 10 here. So somehow we have to make this to base 10 to apply this formula. So I'm going to get rid of this 4. I'm going to move it back to this. Good. How do I do this? There's a formula we have, log of a exponent m equal to m log of a. So if we are like this, we can write it like this. So I can move this one here. So it's going to have 1000 log of x cubed to the power of 4. This will give me 1000 log of x to the power of 12. Agree? So now instead of 1000 here, I write 10 to the power of 3. Good. What should we do if we have like a to power m to power n? What do we do with these two exponents?
Multiply them.
It will be m times n, correct? So this is my m and that's my n. I know it's huge, but we don't care. This is m, that's n. If you multiply them, you get 10. You get 3 log of x to the power of 12. Now, can I use this formula? No. This formula, Megan, you said yes. This formula happens if there is a 1 here. It's very important. We cannot negotiate here. Whatever, we don't play with the formula. I mean, here I cannot say, oh, the base is 10, then the answer is x to the power 12. No, we need to get rid of this 3. How do we get rid of it? We put it on the exponent here. So this will be 10 log x to power of 12 to power of 3, which gives us log, where's log coming from? 10 log x to power of 36. So now we can apply this formula. This is 10, this is 10. The answer will be x to the power of 36. All right. So what you guys need to do, you guys need to pause this video and redo it one more time by yourself. So this is what the way I solve it, that's a technique that you're gonna apply it for your homework or your exam. So you learn a technique in exam. If you see instead of x cubed, if you say x to the power 4, or instead of 1000, if I put 10,000, so you know what you need to do. Good. It would not be surprising exam. It will not be something that I didn't go over it in the homework. So have a good feeling that you're capable to do it. All right, let's do another homework question. So far, not bad. I'm able to solve 5.2. 5.2, 21. Chapter 5, section 5.2, question 21. They're saying a bank account is growing by 2.5% per year. So please do, I know most of you guys don't like this type of question, but again, I said that earlier that you guys just like it for this week or for this exam. Write a good note for yourself, how do we solve? And they're asking us, find the doubling time. So doubling time, and you have to round to the nearest integer. So in your note sheets, we have y equal to a times b to power of t. We have y equal to a e k t. We have b equal to p1 plus r over n to power nt. So you should be able to find out which formula to use. Benas, can you tell me which formula should I use here?
The first one?
Very good. So we eliminate. There is no components word in that problem. They said per year, just once a year. So, I mean, this n is 1, which will be same as this one. And it's not continuously, so we don't use this formula. So we're going to go with the first one. The interest, so this growing by 2.5% per year. So this is our R. R equal to 1, oh, no, 1. R equal to 0.025. We are looking for doubling time. How long does it take? For example, if we have $100, this $100 become $200 at 1 plus 0.025 to power of t. I used 100. You could put 500. You could, we don't care what initial value is. If this is a, this will be 2a. That means if you divide, you're always going to get 2 the other sides. So it would be 2 equal to 1.025 to the power of t. Good. So we are looking for this t. I don't want to solve all of them for you guys, but just hints. This is unknown. Unknown is exponents. Can we make them same base? No. Should we take a log or ln? We use log because we don't see e. So I'm going to take a log here and log over there. Good. So we're going to have log of 2 equal to t log of 1.025. This t comes here, followed by the properties. So if you're looking for t divided by log of 1.025 divided by log of 1.025, you get your t. Log of 2 divided by log of 0.025. It says round it to the nearest integer. If you do this, you will get 28.071. Nearest integer will be 28. (5.2), number 8. I solved this question in one of the YouTube, is on YouTube. The question is, this is chapter 5, section 5.2, question 008. The question is, convert Q equal to 12.963 to power of T to the form y equal to a e to power k t. What is a and what is k? Should I solve this one? I mean, I solved this in the YouTube. I mean, exactly, not exactly the same, but different number. So A, so this is this what we have. This T is the exponent of this one. So there is no way I can break 0.963. So that means this T, so we have e to power kt. This is same as e to power k to the power of t. So this base of t should be equal to this parenthesis because the top t are same. So then a should be 12. There's nothing left, so a gonna be 12. So I'm gonna write e to power of k equal to 0.963. All right. So we're looking for k. How do I solve for k?
Natural log.
Yeah, I mean, this exponent, we're looking for unknown. We're gonna solve for k. How do we solve it? There is an exponent. We cannot make them same base. We left with taking a log or natural log. Because is ln, because as e, I take ln here and ln there. Not a good color. So now the k will come over here. We have k, ln of e equal to ln of 0.963. ln of e is 1. So k equal to this. If they said exact, you leave it like this. If they said rounded, you will round it. $5.39. There's another question that I solved. Please, in YouTube, I'm not going to email you guys that what video I posted up. You guys, please subscribe me. Anytime I post a video, you should see a new video as in your email. All right. This question we have, so this is chapter 5, section 5. Oops. Section 5.3, question 009. What is the equation of asymptote of the graph? So we're looking for equation of the asymptote. We have horizontal asymptote, which always y equal to k. Then we have vertical asymptote, which is x equal to, for example, b. Okay, we have only two types of equation. What we have, y equal to 10 to the power of x. 10 to the power of x, if we graph it, it will be something like this. How do I know it? Because it's exponential function. It's like a b to the power of x. A times b to the power of x. This is huge exponential form. What is a, do we have vertical asymptote? No, there is no vertical asymptote, but we have a horizontal asymptote, which is this one. That means as x goes to negative infinity, y gonna go 0. So y equal to 0 will be the asymptote. Part B, so a equal to y equal to 0, b y equal to 2 to the power of x. What do you think about this one? What is the asymptote for this?
0, y equals 0.
Yeah, if you graph this one, you will get similar, same thing. But I mean, 2 to the power x might be like this. This is 2, I mean, no. It might be, well, I don't know. I mean, they're gonna go from same point. But again, it would be exponential growth, and then x goes to negative infinity, y equal to 0. Again, we have y equal. So you need to write y equal to 0. Part C, they said y equal to log of x. Log of y equal to log of x is inverse of y equal to b to the power of x. Or if you use a calculator, if you graph this one, you will get something like that. That's a graph of log of x, which is inverse of exponential. Here you see we don't have any horizontal asymptote, but we have a vertical asymptote. This will be the vertical asymptote, which is x equal to 0. This line is x equal to 0. All right. This was 5.39. Last question. All right, let's to the last question is, all right, this is on the practice exam. Chapter 4, section 4.4, question 18. We have a sum of $750 is invested for 8 years. And the interest is compounded quarterly. There is 1,000 in the account at the end of 8 years. They're saying, what is the all right, word problem, correct? Word problem, and about the money. So, you know, we need to pick a formula. We see word component, correct? Component means we need to use the formula B equal to initial value 1 plus R over N NT. So here we are looking for yearly rate, which is R, and R is here. So let's see, what do we have? Initial value is 750, correct? 750. 1 plus R we are looking for. N is 4, so quarterly, every 4 times a year. And T is 8, so 8 times 4, and the amount will be $1,000. So we came up with the equation. If we didn't know this formula, then we had problem. But now you know it, so it will be 1,000 equal to 750, 1 plus R over 4 to power 32. We get rid of 750. I mean, this is algebra. You should be able to solve it. We get 1,000 over 750 equal 1 plus R over 4 to power 32. So how do I solve for R? Should I use log or natural log or same base? Do we need to go through the log? Megan?
You should use log.
Should we use log? We use log or natural log if the unknown is exponent. But what we are looking for in the base, there's nothing to do. We don't need to take log. We will make this to the power of 1 over 32, correct? This is 1 over 32. The 32 is gone. So anytime you see a complex equation, don't just bring the log in. So now we have 1 plus R over 4 equal to 1,000 over 750 to the power of 1 over 32. So you calculate this. Then you got a -1, correct? Then you multiply by 4 to get rid of 4. Then you're done. Then you got to multiply this by 4 to have R. In this example, R was 3612, which is 3.612%. I mean, if you do all this work, but at the end you don't round it correctly, again, you don't get any points. All right, so are we done with the homeworks? Any other homework question?
Actually, I just have one quick question. So for the formula B equals P times 1 plus R over N, if it's decaying, would it be 1 minus R over N?
Well, here we are solving for R, correct? If it was decaying, if your $750 become $450, when you solve for R, R will be negative. You will get negative R. And the negative R tells you that you are, it tells you this is going to decay, yeah.
Okay, so you don't change the formula at all?
No, you don't change it. So this R, for example, your R will be negative 0.3, for example, but you are not going to submit negative 0.3. We don't have a negative interest rate. You will say decaying by the rate of 0.3, correct? Any other question?
Just one. In any of the videos you posted, did you by any chance go over 5.1 question 36BD?
What is that?
It says express the following in terms of x without natural logs. And for example, the first part was just e to the power of ln parentheses 3x plus 4.
I mean, how long did you spend on this to solve it?
Quite a bit.
What number is that?
5.136 BD.
5.1 36 BD. In the next, we have only 2 weeks left, guys. You guys need to spend 4 hours a day on this. I will solve this one. Chapter 5, section 5.1, question 036. So this course that you're taking on summer, this is supposed to be on 4 months, correct? So I'm putting everything in 1 semester to a few weeks. So you're taking the class, so you please put as much as time as possible. They're asking us, express the following in terms of x. E to exponent ln of 2x plus 3. That means we have to get rid of ln. What formula do we have here? We have a to the power of this. If there is a base here, to the exponent log of base, same base, the answer is x. So we have the same thing for ln. ln has a base e, invisible e here. So if you have ln of x here, the answer will be x. So e to power ln of x, the answer is x. So again, invisible e, whatever is here will go there. So 2x plus 3. Part D, this was A. Part B, ln of radical, cube root of e to power of x. So the radical, if you have radical a m to power of n, this is a to power m over n. So I'm going to apply this form property. So this is going to be ln of e to power x over 3. Question? So I made the in radical in terms of exponential. So now this will be front of ln. It will be x over 3 ln of e. ln of e is 1, so the answer is x over 3. All right. When I solve it, it's simple, correct? So again, my suggestion is only practice and don't have a feeling that there's a trick in it. No. You have page of formula. It would be great if you solve this one by yourself. Believe me, it feels great. Also, you get so much confidence that you solved it. So more practice like this. I mean, you can just Google it to have exercise on natural log, how to simplify. So those exercise and practice makes you be good. All right, any other homework question? Good, no question. Got it. Deal. Let's go to some business. Question, Tamir, here? You're looking at any part here is bothering you?
No.
Okay.
No, I'm good now. Thank you.
Very good. I mean, I'm happy to solve, but I don't want to make you guys lazy. I mean, I've experienced, the way I solve, people like it, but on the other hand, you get used to the way I solve. You don't spend that much time at home. So let's ask Kayvon. Anyway, so I'm gonna over chapter 6. On chapter 6, there's something that you already know. I give you guys a graph, and we're gonna shift it left and right, up and down. But now we're gonna see if we're gonna stretch it or compress it vertically and horizontally. So it's more details. All right. Are you guys there or is tired? Let's see who's. So, oh, let's talk business. So I'm gonna, for chapter 6, I'm gonna post a homework, correct? When I when I give you guys homework due next week, please do not start next week. You need to start right now. You have to spend 4 hours a day on this course. So please do not email me, but don't try to solve on the same day. It's impossible. It's impossible to do it in the same day. And so I give you guys enough time, but your job is to finish it a few days before that. I will have a quiz on this chapter for you guys. So what you will see quiz online. And then for chapter 7 and 8, which I will cover it tomorrow, it will be one exam. Chapter 7 and 8 is something from Math 130, trigonometry. I will make one video what topic I'm looking for that you guys should know for calculus. So I only go over the important part of trigonometry. You will have an exam on that, and then we go chapter, so let's see. So we have chapter 6, 7, 8, and 9 actually. Good. Trigonometry. So 3 chapters about trigonometry. So you will have one exam on chapter 7, 8, and 9. So I give you guys practice exam. You will practice those questions, and I give you guys exam related to that practice exam. If you go over the homework and practice exam and the exam, that's good enough for the calculus. That's what you need to know for the next class. But if you rely on somebody else, if you want to make your friend take the exam, that would not get it. It would be not good. It will not. Please don't invest on that. And I give you guys extra time that you're able to do research. You can just Google it. You can just open the book and see how do you solve it. Okay. The concept is I would like you guys to review all the trigonometry and then be ready for the calculus. Any question? Any complaint? All right. Do you guys hear me? Okay.
Yes, yes.
That's good. That's good that you guys hear me. So everybody has a camera, correct? I know the camera is off, but it's okay. But for final exam, camera going to be on. And okay. Shift. This is a formula that we applied on chapter 2, I believe. If I give you guys a function or a graph, like if you had a graph like this, that's f of x. If I say f of x plus 5, you move this one 5 units up, correct? It will be exactly the same. It was minus like a 3, we shifted 3 units down. All right, those are transformation. If I say y equal to f of x minus 2, anything we add and subtract inside, we're going to go horizontally. If it's minus 2, I mean, this is 2 here, 2 is positive. The formula has negative. So if h is positive, which in this case is positive, we go h units to the right. If it's negative, we go h units to the left. In this case, we go 2 units to the right. For example, 1, 2, it will be something like this. Even and odd function. We learn that if f of negative x equal to f of x, the function is even. If f of negative x equal to negative f of x is odd. For example, y equal to tangent of x. Let's start chapter 7. Y equal to tangent of x. Is this even, odd, or neither? No, let's put neither. Or neither.
Is it neither?
Ella. Anybody else? So in order to say this is even and odd or none of them, we need to calculate f of negative x, correct? If you see both of them has f of negative x. We calculate f of negative x. If f of negative x equal to f of x, exactly the same as original function, it will be even. If it's negative of that, it will be odd. If it's none of them, it will be neither. So I'm going to calculate f of negative x. This will be tangent of negative x. Tangent of negative x, in your note sheet, one of the identity, tangent of theta equal to sine theta over cosine theta. So instead of tangent, I'm going to put sine of negative x over cosine of negative x. In your note sheet, sine of negative x equal to negative sine of x, and cosine of negative x equal to cosine of x. We learned that cosine is even, sine is odd. We learn in trigonometry. How do we know it? From the graph. So instead of sine of negative x, I can put negative sine of x. And instead of cosine of negative x, I can just put cosine of x. What is sine over cosine? It will be tangent of x, and negative is here. So negative tangent of x. So is this even and odd?
Odd.
Very nice. So tangent of negative x become negative tangent of x. That means f of negative x equals negative f of x. It will be odd. So if the function is even, has a symmetric about y-axis, that's another property of even. And if is odd, is symmetric to the origin. Let's have a couple examples on this. This is f of x. Is this even, odd, or none? What do you think? So if I give you guys an equation, you will plug f of negative x. If I give you a graph, Megan,
I'm not sure.
so we said on the previous note, even, symmetric to the y-axis. That means y-axis will divide the graph. For example, this one. The y-axis, it divides the graph. Symmetric, this distance equals that distance. Odd, or symmetric to the origin. This is a point. In whatever happens there, gonna be happen over there. In the point 0, 0, it will be, if you get this part of the graph and mirror it to the point, you will get that point. That means symmetric about the origin. So now let's go to our question. Is this even or odd? Or none? It would be none of them, correct? Is not symmetric to the y-axis. Symmetric to the y-axis, that means this y should cut the graph exactly half, which the graph is there, it doesn't even touch the y. Origin, whatever, if you had the graph like this, if this 2 was part of the graph, they would be odd because reflected to the origin, but we don't have the other parts. So with none. Another example. This one.
Is it even?
Yeah, I mean the y, I was trying to make it even. So the y-axis, it cut the graph. It means even. This one?
Odd.
None is not exact. Yeah, I mean, I was trying to make it odd. You're right. Has to be exact. I mean, the way I draw it, I mean, it's not, but has to be whatever is going on here has to be over there as well. Or here and there, that means it's odd. All right, origin. If it's not, we're going to say none of them. So you know about symmetric now, x-axis and y-axis, even and odd. Okay, let's have one spicy question. H of x equal to 1 plus x squared divided by x minus x cubed. They're asking us, they're saying, show that the graph of the function h is symmetric about the origin. Tamir, you're in my screen. How do I show this?
First, would we have to solve the equation first before we do anything?
Solve. Don't make it
Like-
difficult. I don't want to solve it here.
We don't do anything to the equation first.
We don't do anything. We go to the next question. What did I do to my screen? It's all messed up. Lucas, what do you think?
So it's asking, it wants us to show that it's odd.
Beautiful. Very, very nice. So if we graph it, and I mean they said show symmetric about the origin, that means whatever happening here has to be happen there. Good, that was the origin. If you connect it to this, if you connect it to this and continue, that means it's symmetric to origin. But we don't want to use a graphing calculator and then print it and show this is origin. We cannot. I mean, if I give you this question, I mean, you cannot just point all the point on this part to the origin and continue and say, oh, this is symmetric about the origin. It's not going to work. So, but we're going to do it algebraically. Algebraically, as Lucas said, is symmetric about the origin if is odd, correct? How do we know a function is odd? When f of negative x equal to negative f of x. All right, so let's do this. So that means if we prove h of negative x equal to negative h of x, then we are done. So I'm going to calculate h of negative x. H of negative x will be equal to 1 plus negative x squared divided by negative x minus negative x cubed. Agree? I just substitute negative x for the x. Now I'm going to simplify to see, do we get negative h of x? Equal to, line here, 1, negative x squared, I get positive. Good. This negative x will be negative x. Negative x cubed will be negative x cubed. Then gives a negative negative gives you positive x cubed. All right, Tamir, I like the way you're looking at it.
Yeah, I'm just
Very good.
observing.
Very good. Hopefully, I know you are. So what we got here, is this exactly like this?
Not a
Very good. It has to be
Exactly.
exact. If it's exact, that would be even. So it's not even. But now we need to see if this one, if what we got equal to negative of that. If I multiply this by negative, do I get what I got? Do we get this one? So little algebra here, 1 plus x squared is same. So I'm going to make 1 plus x squared. I'm going to factor the negative from the denominator. I'm going to have x minus x cubed. Do you guys see that? At here, I pull the negative out. Then the negative x become positive x. This positive become negative x cubed. That means if I multiply back, I get some, if I multiply negative, I get the same thing as this one. So now I'm going to move this negative over here. So this will be negative 1 plus x squared, x minus x cubed. Correct? This part is exactly same as h of x, and the negative is right there. that means h of negative x become negative h of x. Therefore, this is odd, and definition of odd is symmetric about the origin. All right, so we proved it. Any question?
If a graph goes through the origin, is it possible for it to be odd because that's still a point on the y-axis? I mean, even, not odd.
Say again, please.
So if a function goes through the origin, is it possible for it to be even because it still is on the y-axis?
If a function goes through the origin, cut the y-axis.
Yeah, if it goes through the origin, can it still be even somehow?
Oh, very good question. Yeah, I mean, this x squared will be even.
Okay, thank you.
Very good, very good. So those things is your part. I mean, you get even and odd, correct? This is some, let's say, new topic. You got shifting graph, and reflections. So symmetry we talked about. So those things you need to just do some research on it. Just more practice. My homework and all the exercise that I put is not enough to learn it very well. And for the exam, I would like you guys to cheat. How to cheat? Make a good note sheet for yourself. Have few pages of note to be able to refer it which question for which question that you have. But it would be very bad that you've passed my class, but you have no idea about even and odds. That would be flag for the next course. So all those, I mean, you, as long as you know what even and odd is, that's great. There are questions like this about even and odd, which is kind of spicy, but at least you have some idea how to do it. And the idea is enough. If you multiply a function by constants, by this k. For example, let's say we have a graph, this one, x squared. If I say 5 times x squared, what's going to happen to this graph? So you see, we are not adding and subtracting. If we don't add and subtract, that means we're not going to shift it up or shift it down or left to right. Okay, don't do that. When you're multiplying, the graph will stay same place. So this will stay same, but it depends to the number that we multiply. Sometimes it gets wider like that. Sometimes it gets narrower like that. So there's a word, vertically stretched. I mean, I get the graph, stretch it vertically. When that's happened, when that k, the number that you multiply, is more than 1. All right, so in this case, 5 is more than 1. So you will stretch it vertically. How much you're going to stretch? They call it by factor of k, or factor of 5. For example, x squared, 5x squared. If it's 0, all of them are 0, so the point is same. For example, x equal to 2, y equal to 4 on the original. What for 5x squared? The y will be 20. I mean, y will be 20. So we stretch it by factor of 5. What you need to know, just you need in exam or quiz, you're going to say, oh, we are stretching by factor of k. If k is between 0 and 1, like 0.2x squared, it will compress, vertically compress by a factor of k. So that was outside of function. Now we're dealing with inside of function. I get sick of this color. Let me remove this. Whew, much better. Much we are. Okay. So now we are multiplying k inside. That's very important, guys. So same as we had f of x minus h plus k. For outside, if it was plus, we go up and down. If for h, I mean, we do right and left. So now for the k here inside, we do horizontal. If k is more than 1, we horizontally compress by a factor of 1 over k. So anytime inside the function, we do opposites. So 1 over k, if k is more than 1, 1 over k when it's k is between 0 and 1. And if you have y equal to negative f of x, so we reflect, if it was like this, we reflect on the x-axis. If negative is outside, we reflect it on the x-axis. If it's negative is inside, we reflect on the y-axis. Are you guys okay? Andrea, question? Lindsay, be quiet today. Good.
I just have a quick question.
Sure, I'm glad I asked.
How do you know when to use these kind of equations, like horizontal and vertical?
So they ask you, they give you a graph. That's a very good question. They give you a graph. For example, I give you a graph like this, okay? I'm call this one f of x. And I ask you graph y equal to f of x plus 3. So you graph it, you shift it 3 units up. Good. Or I give you another graph like this. This is g of x. And y equal to 5g of x. To graph 5g of x. So this is going to be, so this point was 1, 2, 3, for example, negative 3. This is 3. So 5 times g of x. So we will graph this one. Wow. How do we graph this, actually? The x value, for example, here is negative 3, 0, correct? Where this point gonna go, this is gonna be 5 multiply value of y. So this point will stay same. But this 3 will be 15, gonna go 15. This point was 2, 2. The x will stay same, but the value of y will be 10. And this point gonna go like this. So they ask us to graph it. Or I give you a point on 2 and 3 and ask you what this point will go if I make it 3 f of x minus 2 plus 5. If 2 and 3 is on the graph of f of x, where that point will go after those transformation. Did it confuse you? A little bit. That's good. Let me pick one of the homework question. They're saying write a formula for the transformation of f of x equal to root x. So I give you guys root x, and now they're asking us part A, what is y equal to 6 f of x minus 8? And what is y equal to negative 1/3 f of x? That's another type of question. So you know we have a parent function. They call it original function that they call x. So on part A, two things happen. If this is a graph, -8, we're going to shift it 8 units to the right. And 6, we're gonna stretch it vertically by a factor of 6. So this is gonna be, for example, like that. But we don't care about the graph. They just ask us, this will be 6 radical x minus 8. This will be the new graph. Okay. First, f of x equal to root x, f of x minus 8, x minus 8, I plug it there. It's going to be radical x minus 8. The 6 is outside, it goes outside. So this will be your new graph, new functions. This one, f of x stays same, so f of x is root x. Only negative 1/3 going to be multiplied by this. And you're done. Pretty simple chapter here, but tomorrow for sure I will go over this for the 20 minutes, so half of a session tomorrow. I will go over some of the exercise in this chapter, and then I'm going to start chapter 7 and 8 and 9. So one more time, 1 more minute left. You guys need to put 3 to 4 hours a day on this one. Only we have 2 weeks left. A final exam, it will be, final exam will be final exam. It will not going to be the same as the exam you're going to take. I give you guys enough time, but you should know what you're doing, because it will be a camera.